Hi, today we're looking at GCSE Maths. This is the Pearson Edexcel exam board. We're looking at the paper from summer 2024. So this is paper 1, which is the non-calculator paper, which was actually sat on the 16th of May 2024. So, question 1. Write the number 18,475 correct to the nearest 1,000. So the way I like to look at this is to say, well, which thousands is it between? Well, it's going to be between 18,000. So if we just took all of those numbers off, we'd end up with 18,000. And above that number, the next 1,000 would be 19,000. So we know it's between these two. What would halfway be? Well, halfway between 18,000 and 19,000 is going to be 18,500. So which half is this going to fall in? Well, 18,475 is before this, so it's in the first half, so we're going to round it to 18,000. Question 2. Write 0.3 as a percentage. Okay, so 0.3, if we want to make it percentage, we're going to multiply it by 100. So we're going to move the decimal point once, twice. Now we're going to have to fill that in with a 0, so we have got 30%. You might also think of that as 3/10 and think, well, if we want to make it over 100, we'd have to add a 0 at the bottom and also a 0 at the top. So we still get the 30%. Question 3. Write down the mathematical name for the type of angle marked Y. So remember, we've got a few different types of angles. We've got an acute angle. That's where we've got something less than 90 degrees. We've got a right angle, which is exactly 90 degrees. We've then got an obtuse angle, like this, which is more than 90 degrees, but less than 180 degrees. And then we've got something like this, which is more than 180 degrees, which is a reflex angle. Question 4. Write these numbers in order of size. Start with the smallest first. So when we've got decimals, especially where we've got some with a different number of decimal places, I like to write one above the other. So 0.21, 0.2, 0.03, 0.1. We're lining them up with the zeros in the decimal place, and then 0.16. Now, to make them have the same number of decimal places, we can just fill in zeros at the end. Now, because they're the same at the front, the whole number part is just 0, we can pretend that's not there. And so, well, let's just compare these numbers in size. 21, 20, 3, 10, and 16. So the smallest number is this one, 3, then 10, then 16, then 20, and then 21 at the top. Okay, so that's the order we need to put them. So the first one was this one, 0.03, because they've said start with the smallest number. So then the next one after that was they just had it 0.1. Then the third one was 0.16. Fourth is 0.2. And the fifth one, 0.21. Okay, question 5. Find the square root of 64. So that's the number when multiplied by itself gives you 64. Now, if you can't remember, you can try going through your square numbers. So let's start off with, well, 1 squared is 1 times 1, which is just 1. 2 squared, 2 times 2 is 4. I nearly put a 2 there. 3 squared, so 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. And 8 squared, 8 times 8 is 64. So you can go through them one at a time. And if you need to sort of use your hands, 8, 16, 24, or even count up as you're going, that's fine. So the square root of 64 is just 8. So it's the number that when you multiply it by itself gives you 64. Question 6. Ryan buys 4 cakes at £1.30 each, 2 identical tins of soup. Ryan pays with a £10 note. He gets £1.80 change. How much does Ryan pay for each tin of soup? Okay, so let's think. Well, let's start off with the total price of the cakes, because we know we've got 4 of them at £1.30 each. Now, when I'm multiplying numbers like these, where we've got decimal places and zeros, I'm going to ignore the decimal point and the zeros. We're just going to say, well, let's make that 4 times 13. Okay, and I'm going to put the decimal point and everything else in afterwards. So we'll start off with 3 times 4, which is 4, 8, 12. Carry the 1. 1 times 4 is 4, plus 1 is 5. Okay, now what we need to do is we need to put the decimal places in. So we had 1 decimal place here that we've taken out. The point should be there, so 1.3. So we're going to put the decimal point in 1 there. So we get 5.2. So that's 5.2 pounds. But we wouldn't say 5.2 pounds, we would say £5.20. Okay, so that is the cost of the 4 cakes. And we also know that he got £1.80 in change. So what we want to do is take both of these away from the £10 note. So let's do, you could add them together and take them off, which gives you nicer numbers, but I'm going to do one at a time. So we're saying we started with £10 and we want to take off the £5.20. Okay. Now with this one, I'm going to keep the decimal point in, but I'm going to add zeros on here so we've got something to take away from. 0 minus 0 is 0. 0 minus 2, well, we can't take 2 away from nothing. So we need to get something from the previous number. We've got nothing here to borrow from, it's 0. Now this one, we can reduce it by 1 to make it 0, and pass 1 over to make it 10. Now we still want to get something over here to take the 2 from, so we reduce that by 1 to make it 9 now. And this now becomes 10. So now we can do 10 minus 2 is 8. Decimal point. 9 minus 5 is 4. So we've got £4.80. So that's the £10 taking off the cost of the 4 cakes, which is £5.20. Now we had £1.80 left in change, so we can take that off as well now. 0 minus 0 is 0. 8 minus 8 is 0. Decimal point. 4 minus 1 is 3. So we've got £3, which must have been spent on the 2 tins of soup. Okay. That's for the 2 tins. We want to know how much he pays for each tin, so we want to divide 3 by 2. So think of this as like the bus stop method. You'd say, well, 2 goes into 3 once, remainder 1. We've got nowhere to put the remainder, so we put a 0.0 and add the 1 here. So we've not changed the number. Instead of 3, we've just got 3.0, but it means we've had somewhere to put the remainder. So we can now say 10 divided by 2. So 2, 4, 6, 8, 10. That's 5 times. So we end up with £1.5. But again, because it's money, we need 2 decimal places. So that's £1.50. And remember, don't put a P at the end of the number. If you've got the pound at the front, don't have the P. That's only if you're talking about the actual number of pence. So for example, 150 pence would be okay, but £1.50, no p. Question 7. The table shows the number of hours that Lena and Pavel worked on each of 4 days last week. So you can see on Wednesday, Lena worked 6 hours, Pavel worked 7. On Thursday, Lena worked 9 hours, Pavel worked 6. On Friday, Lena worked 8 and Pavel worked 5. And on Saturday, Lena worked 6 hours and Pavel worked 6 hours as well. On the grid, draw a suitable diagram or chart for this information. Okay, so it doesn't tell you exactly which chart to draw. You could draw maybe two line graph, so a line for Lena and a line for Pavel. I'm going to do a double bar chart, I think, just because I find those quite straightforward to draw. So we're going to have 4 days, but we need to have each of them split for Lena and Pavel. So let's see, we could have, if we have a bar for each of them, that could be Wednesday, Thursday, Friday, and Saturday. Yeah, that works. So Wednesday, Thursday, Friday, Saturday, and then I'm going to have 1 bar for Lena, 1 bar for Pavel on each day. We need to have the scale or the numbers going up there. Actually, before we do that, I can just put my label on today. Now, the biggest number we go up to is 9. So let's see if we can, how to fit these on. Well, we can just do, if we start at 0, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. I'm actually going to write 10 on there, just so we've got it on, but we shouldn't need to go as high as that. And if you just wrote the scale on in going up in 2s instead, that's fine. You don't have to write every number on there. But we do need to label it. So we've got number of hours. So on the Wednesday, Lena worked 6 hours and Pavel worked 7. So for my first bar, I have 6 for Lena. And then 7 for Pavel. Now I'm going to have my bars all touching. It's up to you if you want them touching or not. I think it's fine to touch. But also what I'm going to do, so I can distinguish between the 2 people, I'm going to draw a key. So I'll do that over here out the way. So we're going to have Lena and Pavel. And for Lena, let's do diagonal lines like this, and for Pavel, let's do some vertical lines like that. Okay, so if we use the ruler, so Lena's going to all be like this. Doesn't need to be too exact, but nice and tidy. And Pavel, we're going to have, oh, wobbled a bit there. It's just going to have some vertical lines. Okay, it should look clearer when we've got the rest of the bars in as well. So for Thursday, we've got 9 hours for Lena and 6 for Pavel. So we're going to go up to 9 for Lena. And 6 for Pavel. So again, we're going to do our pattern here. So Lena's got all these diagonal lines. And Pavel's the vertical lines. It's good to have a key like this, but do pick something that's nice and easy to do. You don't want to spend too much time drawing your bar graph. Lena worked 8 hours on Friday, Pavel worked 5. So this is just my choice to do it as a bar. You can do it as a line diagram. So we want 8. And then 5. And of course it is important that you get them the right way round. We don't want to get Lena and Pavel mixed up. So I started with Lena on the left, so she's going to stay on the left with these bars on each day. And on Saturday we had 6 hours for each of them. So 6 is up here. And then vertical bars for Pavel. Okay. And there's my graph. Okay, question 8. OA, OB and OC are 3 straight lines. So 1, 2, 3. Work out the size of the angle marked X. Okay, so I know that the total number of degrees in a circle is 360. So if I add these two together, take them away from 360, what I've got left is going to be X. So we want 220 plus 90. 0 plus 0 is 0. 9 plus 2 is 11. Put the unit, carry the 10. 2 plus 1 is 3. So 310 degrees for all of this. So this is going to be the leftover bit. So we're going to take 360 and subtract the 310. 0 minus 0 is 0. 6 minus 1 is 5. 3 minus 3 is 0. So we're left with 50 degrees, and they put the little degree sign in for us already. Give a reason for your answer. Okay, well, it's just for 1 mark. So basically the thing that we used, which I mentioned, was the fact that the number of degrees around a point add up to 360. So we just want to write that. So we can put degrees or angles at a point total 360 degrees. I say degrees might be better than angles, but it's fine. They're going to understand what you mean and you'll get your mark. Okay, question 9. Here is a number machine. So you have your input, multiply it by 2, subtract 10, and you get your output. A. Work out the output when the input is 13. So 13 times 2. 2 times 3 is 6. 1 times 2 is 2. So you get 26. Then you need to subtract the 10, or minus 10. So 26 minus 10. 6 minus 0 is 6. 2 minus 1 is 1. We get an answer of 16. Now, this is a number machine, so it's not order of operations. We're not saying, you know, which one do we have to do first. We're literally doing 1 step at a time. It wouldn't actually make a difference on this one, but we do 1 step at a time, each box separately. Okay, part B. Work out the input when the output is 28. So we're going backwards now. So if we're going backwards, we need to do everything in reverse. So we're starting with 28, and the reverse of the inverse of minus 10 is going to be plus 10. So 8 plus 0 is 8, 2 plus 1 is 3. So we got 38. And now the inverse of multiply by 2, or times 2, is divided by 2. So 38 divided by 2, using the bus stop. So 2 goes into 3 once, remainder 1. 2 goes into 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, 9 times. So we get back to an input of 19. And if you want to check it, you can now put the 19 in, multiply it by 2, take away 10, and you'll get back to 28. Okay, part C. This is for 2 marks. Here we go. Show that there is a number for which the output is the same as the input. Okay, so we can use a bit of algebraic notation for this. So instead of a number, we're going to call it x. Okay, so we've got this number x. Actually, let's see this number machine up here again. I'll do it up here. So if we've got a number x, we're going to multiply it by 2. Then we're going to take away 10. And then we're going to get the output. But the output's going to be the same as the input. So we're going to have our x, which we multiply by 2. So that's 2x. Then we take away 10. And we're going to end up with what we started off with, which is x. 2x minus 10 equals x. That's what the number machines told us. We've just created this. Now, all we need to do is to solve this. So we want to get the x's together and the numbers together. So I'm going to move this number to the other side. So when we do that, the sign changes. So instead of minus 10, we're going to end up with plus 10. So we've got 2x. The minus 10's gone. We've still got the x here. But now we've got plus 10. And now this x we want to get rid of. So we're going to move it to the other side. It becomes minus x. So if we've got 2 x's, take away 1x, we're just left with 1x. We don't need the number, so we can just write that as x. And we've still got the 10 on the other side. So we've got x equals 10. And if we wanted to test that out, 10 times 2 is 20, take away 10 is 10. So it works. So we can leave that x equals 10. Question 10. There are 24 cows and 36 sheep on a farm. Write as a ratio the number of cows to the number of sheep. Give your ratio in its simplest form. Okay, so we can do this with a nice simple little table. We've got cows, we've got sheep, 24 cows, 36 sheep. So we want to get them into their simplest form, so that means looking for common factors or numbers that go into both of them. Now they're both even, so we could divide them by 2, and you could do that and maybe do that a couple of times, but actually I can see that these are both in the 12 times table, so I'm going to divide them both by 12 straight away. So you could do it in multiple steps, and I know that 24 is 12, 24 is 2 12s. So we divide it by 12, it goes in twice. 36 divided by 12, 12, 24, 36, goes 3 times. So our ratio in its simplest form, from cows to sheep, is 2 to 3. Note that if they ask for the ratio of sheep to cows, then we'd swap it round the other way and it would be 3 to 2. So it is important which way round they've asked for it. Question 11. Work out minus 12 divided by minus 4. So when we've got negative numbers in a multiplication or division, start off by ignoring the negatives. So we just do 12 divided by 4. Well, 4, 8, 12. The answer is going to be 3. Then you say, have I got an odd number of negatives or an even number? If it's an even number, they cancel out. So it just stays as 3. If we had one negative but not the other, then the answer would be negative. So it's simply 3. B. Find the value of 2 to the power 5. So that means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Okay. Well, 2 times 2 is 4. Multiply 4 by 2 is 8. 8 times 2 is 16. And 16 times 2, you can do it column method if you want, is 32. If you want to write them down each time, as I say, you could do 2, 4, 8, 16, 32. However you want to show it is fine. But it's just remembering it's not 2 times 5. It's 2 multiplied by 2 5 times. Part C. Write one pair of brackets in this calculation so that the answer is correct. So we've got 30 divided by 3 plus 2 minus 4 equals 2. So we're starting at 30 and we want to get down to something quite small. So if we just do 30 divided by 3, well, that's going to go in 10 times. And then it's going to be hard. Adding 2 to 10 is going to get 12. That's not going to work. So we're going to need to divide it by something more than 3. So we can get a smaller number. Now, what about if we put the brackets in here? So we would have 3 plus 2 is 5. 30 divided by 5, well, that would be 5, 10, 15, 20, 25, 30. That would be 6. So 30 divided by 5 is 6. 6 minus 4 is 2. Yeah, so that works. So it's almost a bit of trial and error. We want the brackets in there. But think about, do I want to get smaller? Do I want to get bigger? Do I want to get bigger more quickly or slower? That will help work out where you need to put the brackets to make it a bigger or smaller number that you're either dividing by or subtracting. But yeah, trial and error is the best way. Question 12. The diagram shows a triangle and a rectangle. The perimeter of the rectangle is a quarter of the perimeter of the triangle. Work out the length of the rectangle. Okay, the perimeter of the rectangle is a quarter of the perimeter of the triangle. Well, we can work out the perimeter of the triangle because the perimeter, or P, is going to be all of the lengths added together. So 36, 14, and 30. 6 plus 4 is 10. 3 plus 1 is 4, plus 3 is 7, plus 1 is 8. So we've got 80. Now the perimeter of the rectangle is a quarter of that, so we want 80 divided by 4. 4 goes into 8, 4, 8 twice, 4 goes into 0, 0 times. So 20 centimetres is the perimeter of the rectangle. Now we want to think about how we work out the perimeter of the rectangle. Well, we would add all of the lengths together. So we'd have another 4 over here, and this, we could just call it length. So we'd have 4 plus 4, and length plus length, which we can think of 4 plus 4 is 8, and length plus length, well, that's just 2 lengths, or 2 times length. We know that that is equal to 20, so we can put 20 equals 8 plus 2 times length. Well, let's get rid of this 8 by moving it over to the other side. So remember, it's a positive 8 there, so move it over, it becomes a negative 8. So 20 minus 8. Can't take 8 away from 0. So reduce the 2 by 1, make that 10. 10 minus 8 is 2. 1 minus nothing is 12. So now we've got 12 equals 2 times the length. So if we want just one length, well, we move the 2 across. It's multiply at the moment. We do the opposite, which is divide. We get 12 divided by 2. 2, 4, 6, 8, 10, 12. That's 6 times. So the length equals 6 centimetres. They've already put the units for us. Question 13. There are only £10 notes and £20 notes in a wallet. Ali takes at random a note from the wallet. Write down the probability that Ali takes a note with a value of more than £5. Well, it's either £10, which is more than 5, or £20, which is more than 5. So it's 100%. So we can just write 1 if you want to do it as a decimal, or you could put 100%. Either one's fine. Next part for 2 marks. There are only 1p coins and 2p coins in a bag. The total value of the coins in the bag is 40p. The total value of the 1p coins is the same as the total value of the 2p coins. Simon takes at random a coin from the bag. Find the probability that Simon takes a 1p coin. Okay, so we want to know how many coins we've got in the bag. Well, if the total value of the 1p coins is the same as total value of the 2p coins, so we need to divide 40 by 2. So 2 goes into 4 twice, 2 goes into 0 0 times. So we've got 20p's worth of 1p coins and 20p's worth of 2p coins. Well, 20 divided by 1 is 20, so we've got 20 1p coins. And 20 divided by 2 is 10, so we've got 10 2p coins. So we want to know the probability that Simon takes a 1p coin. So we've got 20 1p coins, but in total we've got 20 plus 10, which is 30 coins. So 30 in total, 20 are what he wants, so the probability is 20 30ths. Or you could cancel the zeros and just say 2/3. But because they haven't said write it in its simplest form, if you wrote it as 20 over 30, that would be fine. Question 14. Work out 273 times 54. There's loads of different ways to do multiplication, so I'm going to do the column method. If you choose to do it another way, absolutely fine. But we should end up with the same answer. Or you can do the grid method, however you want to do it. So I'm going to do 3 times 4, 4, 8, 12. And then do 7 times 4, or 4 times 7. 7, 14, 21, 28. Plus 1 is 29. 2 times 4 is 8, plus a 2 is 10. So we've multiplied everything by the 4. Now we're going to move on to the 5. So we can put 0 in here, because we're on to the tens. We're not going to have any units. 3 times 5, we've got 5, 10, 15. 7 times 5, we've got 5, 10, 15, 20, 25, 30, 35. Plus 1 is 36. 2 times 5 is 10, plus a 3 is 13. So we'll add these two together. 2 plus 0 is 2, 9 plus 5 is 14, 6 plus 1 is 7, 1 plus 3 is 4, 1 plus nothing is 1. So we've got 14,742. Make sure we write it on our answer line. Question 15. Tessa recorded the times that 15 adults took to complete a run. She showed her results in a stem and leaf diagram. Okay, so the key 4, line 5 represents 45 minutes, so 45. So the next entry will be 49, then we've got 53, 57, and so on. Find the median. So the median is going to be the middle number. We know that there were 15 adults. So to work out the median, we take the number n, add 1 to it, and then divide it by 2. 15 plus 1 is 16. 16 divided by 2. 2, 4, 6, 8, 10, 12, 14, 16. That's 8. So the answer's not 8, but it's the 8th value that we want. That will be the median. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 64. Part B, find the range. So the range is the biggest number, or the maximum number, minus the smallest, the minimum. So the biggest number we've got is 81. And the smallest number is 45. So 1, take away 5 we can't do because 5 is bigger than 1. So reduce the 8 by 1 to 7. Pass 1 across. We've got 11 minus 5 is 6. 7 minus 4 is 3. So the range, the difference between the biggest number and the smallest number, is 36 minutes. Tessa also recorded the times that 15 children took to complete the run. For the children, the median was 75 minutes. Compare the times that the adults took with the times that the children took. Okay, seems a bit of a trick question, but we just want to give a little explanation. So we know we're talking about the median. We know that the adults took 64 minutes. The children 75 minutes down here. So we can just say median for the children was higher or longer, because we're talking in terms of time, either we find higher than for the adults. Question 16. Batteries are sold in packs of 4, in packs of 8 and in packs of 12. We've got the pack of 4 is £1.80, pack of 8 is £3.20 and the pack of 12 is £6. A pack of 4 batteries costs £1.80. Well, that's what they've said, yeah. Pack of 8 costs £3.20 and a pack of 12 costs £6. Which pack gives you the best value for money? You must show how you get your answer. So at the moment it's hard to compare because we've got different quantities. We want to sort of work it out as if we had the same number of batteries for each. So what I'm going to do is I'm going to work out the cost per battery for each of these packs. So £1.80, 4 batteries, but I'm going to think of it in terms of pence. So instead of £1.80, I'm going to think of it as 180 pence. That's for 4 batteries. So if we divide it by 4, it'll tell us how much it is per battery. So 4 into 1 doesn't go. 4 into 18. 4, 8, 12, 16 is 4 times. But 17, 18, there's remainder 2. Put it in front of the 0 to make it 20. 4 goes into 20. 4, 8, 12, 16, 25 times. So for the pack of 4 batteries, they're 45p each. Now we're going to do the same thing with the other 2 packs. So instead of £3.20, think of it as 320p. This time we want to divide it by 8, because there's 8 batteries. So 8 into 3 doesn't go, because 8 is bigger than 3. 8 into 32, 8, 16, 24, 32. 4 times, and 8 into 0, 0 times. So for the second pack, they're 40p each. So that's looking at better value already. Let's have a look at the last pack. 12 batteries and £6. So £6, think of that as 600p. And we want to divide that by 12. Now it's not always great to divide by a 2-digit number, But if we think, well, 12 doesn't go into 6, but 12 into 60, well, I know 60 is in the 12 times table. So we've got 12, 24, 36, 48, 60. That's 5 times, and 12 into 0 goes 0 times. So for the last pack, they're 50p each. So the best value for money means the cheapest per battery, which is this one there, which is the pack of 8 batteries. And that was for 3 marks. Question 17. Solve 2 brackets 4x minus 5 equals 18. Okay, remember when we've got a number next to brackets, it means there's a times in there. 2 ways of doing this. A lot of people will automatically multiply out the brackets, which is fine. In fact, we'll probably do it that way. So 2 times 4x would be 8x, and then 2 times minus 5 would be minus 10, equals 18. And then we want the x's on their own, so we're going to move the minus 10 over, so that becomes plus 10. So we end up with 8x, the minus 10's gone, 18 plus 10 is 28. We've got 8 times the x, so we move it across, it becomes divided by 8. So we've got x equals 28 divided by 8. Well, let's look if we can simplify this down. And of course we can divide both by 2. In fact, we can divide top and bottom by 4, I think. So in the top we've got 4, 8, 12, 16, 20, 24, 28, 7 times, and 4 goes into 8, 4, 8 twice. So we've got 7 over 2, and we could keep it like that, or we could write it as 3.5. 7 over 2 is fine. Now, I did say there was another way of doing it. I think this is the way a lot of people like to do it naturally because they just want to expand it. But actually what we could do is say, well, we've got 2 times this bracket. We could get rid of the 2 straight away by dividing by the 2. So we get 4x. So this is our alternative. So 4x minus 5 stays on the left. We've got 18 divided by 2, which is 9, half of 18. Then we move the minus 5 over to becomes plus 5, plus 5. So we end up with 4x equals 9 plus 5, which is 14. Then we divide by the 4. We get x equals 14 divided by 4. Divide the top and bottom by 2, and it gets us down to the same number as before. So you might think this is quicker. Depending on what numbers you get, this could be quicker. It just is. They're alternatives. It's nice to be able to know how to do it both ways because sometimes it's going to be the numbers are just going to make it quicker to do it one way rather than the other. Okay. Question 18. Write down the value of 10 to the power 0. Anything to the power 0 is 1. If you don't believe me, check it on your calculator. Although you can't use your calculator in this paper. Okay. Question 19. Got a shape here, A. Describe fully the single transformation that maps triangle A onto triangle B. Okay, well, the shape hasn't turned, it's just been moved. So we can use a matrix to say how it's been moved. And we split it up into how it's been moved horizontally and how it's been moved vertically. So it's always good to pick one particular point of the shape. So I'm going to pick this point. So that means I'm comparing it to this point here. How many across has it gone? Well, it's gone 1, 2, 3, 4, 5. Okay, so in my matrix, here my little vector, we're going to have 5 at the top because it's gone 5 to the right. And what about vertically? Well, it's gone 1, 2, 3, 4. But because it's gone down, it's going to be -4. So we can say transformation by the vector 5 -4, which tells us go to the right by 5, go down by 4. We did it for 1 point only, but obviously if this point is going across and down, all the other points are going to move by the same amount. Question 20. Here are the first 4 terms of an arithmetic sequence. We've got 1, 5, 9, 13. Find an expression in terms of n for the nth term of this sequence. So the first thing we want to do is to look at how much it's increasing by each time. So we've got 1, 2, 3, 4, 5. So that's adding on 4. And then from 5, 6, 7, 8, 9. So adding on 4 again. So from 9, 10, 11, 12, 13. So we're adding on 4 each time. So what we do is we say, well, 4n, where n is the number in the sequence. So this is the first number in the sequence, that's the second one, that's the third, that's the fourth. So we know we've got 4n is going to be part of this expression, and then we're either going to add a number or take away a number to get it to where we need it. So let's start with the first. We've got 1. 1 times 4. 4 times 1 is 4. But we want to get to 1. So from 4 to 1 we have to take off 3, 2, 1. So we need to take away or subtract 3. Okay, so let's start with the next one. So with n being 2, 4 times 2 is 8. We want 5, so we've got to take off 7, 6, 5, 3. So it should work for all of them. 4 times 3 is 12. Take away 3 is 9. 4 times 4 is 16. Take away 3 is 13. So the expression they want is just the 4n minus 3. So say the way we got this was first we looked at what the sequence was increasing by. Said, well, we're going to multiply that by the n. And then we tried it with one of the numbers and then worked out the plus or the minus as to what we need to get to the value given. And once you've done it for one of the terms in the sequence, it should work for all of the others. If it doesn't, it looks like something's gone wrong. Question 21. Work out 3 4/5 minus 1 2/3. So I'm going to work out, I'm going to turn these into improper fractions. We've got mixed numbers at the moment. And the way we turn them into improper fractions is we multiply the whole number by the denominator. So 3 times 5 is 15. Add it to the top, gives us 19. So we've got 19/5. Okay, so that is the same as that. So again, so we've done 3 times 5 and then added on the 4 to give us 19. And we're going to subtract this fraction, or this mixed number, 1 2/3. So we say 1 times 3 is 3, plus 2 is 5. So we've got 5/3. Because with this one, if you think 1 2/3 is the same as, well, 1 is like 3/3, and then you've got 2/3. And of course, when you're adding fractions, the denominator stays, and you add the top. So we've got 19/5 minus 5/3. You might think that's not really helped us because we've still got different denominators, so we can't do anything with it at the moment. We need to get a common denominator, so we want a number that both 5 and 3 divide into. Well, let's multiply them together. 3 5s are 15. So we're going to write these both as fractions over 15. The sign in the middle stays the same. Now, from the 5 up to the 15, that's 3 times bigger. So we need to multiply the 19 by 3 as well to keep it as an equivalent fraction. So 3 times 19, we do 3 times 9 is 27. 1 times 3 is 3, plus 2 is 5. So we've got 57 fifteenths, which is equivalent to 19 fifths. And the reason that's going to help is because we're going to turn this fraction into fifteenths as well. Now, to get from the 3 to the 15, we multiplied that by 5. So we need to multiply the top number by 5 as well. And 5 5s, 5, 10, 15, 20, 25. So now we've got two fractions, both with the same denominator. So 57 fifteenths minus 25 fifteenths. The answer is still going to be fifteenths. We just need to do 57 minus 25. We can do that over here. 7 minus 5 is 2. 5 minus 2 is 3. We've got 32 fifteenths. We could just leave it there because they haven't said how to write it, but they gave the numbers as mixed numbers to start with, so I'm going to do the same. So how many 15s go into 32? Well, 15, 30. So it goes in 2 whole times, remainder 2, so that's going to be 2 and 2 fifteenths. Okay. There's a part B to this one, and this is for 1 mark. Kevin was asked to work out 2 1/3 times 5/8. Here is his working and his answer. So he said 2 1/3 times 5/8 equals 7/3. So he's turned this mixed number into an improper fraction, which looks fine, times 5/8. So that looks good, happy with that. Then he said it equals 35 over 24. So 7 times 5 is 35. 3 times 8 is 24, so that looks fine. And then he said that is equal to 1 and 9/24. Well, if we do 24 goes into 35 once, which is good. But if we do 35, take away 24, 5 minus 4 is 1, 3 minus 2 is 1. So it shouldn't be 9, it should be 11/24 left over. So that's the wrong bit. So what mistake has Kevin made? We can just put, it should be 1 and 11/24. That'll be sufficient. Question 22. The diagram shows a plan of a floor. Okay, so we've got a few of the distances written on here. Petra is going to cover the floor with paint. Petra has 3 tins of paint. There are 2.5 litres of paint in each tin. Petra thinks 1 litre of paint will cover 10 metres squared of floor. Assuming Petra is correct, does she have enough paint to cover the floor? You must show all your working. So starting point, we want to know how much area we've got for the floor. Remember that area is the inside. Now what we want to do is we want to split this up into rectangles. So we could split it that way, but because I've got a nice 10, and 10 is a good number to multiply by, I'm going to split it this way. So I've got a rectangle at the top, and the area of this rectangle is going to be the length, 10, times the height, 5, which is going to give me 50 metres squared. Now we want the area of this smaller rectangle, which is 6. Now we want this height here. We know 8 is all the way. This bit, 5 is just the top. So this length here is going to be the difference between all of it, the 8, and the 5. So it's going to be 3 metres. So 6 times 3, or 3 times 6, gets 6, 12, 18. We've got 18 metres squared. So the total area is, add these two together, 50 plus 18. 0 plus 8 is 8, 5 plus 1 is 6. We've got 68 metres squared. Okay, so we've got to think about the paint now. We've got 3 tins and there's 2.5 litres in each. So we want 3 times 2.5. But remember, I like to ignore the decimal point and I'll put it back in afterwards. 3 times 5, 5, 10, 15. 2 times 3 is 6, plus 1 is 7. Now the decimal point was in one place taken away, so we put it back in one place. So we've got 7.5 litres of paint. 1 litre will cover 10 metres squared. So 7.5 litres, we need to multiply that by 10. 7.5 times 10, I'm going to move the decimal point once, is going to be enough to cover 75 metres squared. Assuming Petra is correct, does she have enough paint to cover the floor? So she's got enough for 75 metres squared, but we only need enough for 68. So yes, she's got more than enough. Part B. Actually, 1 litre of paint will cover 11 metres squared of floor. Does this affect your answer to part A? You must give a reason for your answer. Well, we had that 75 metres was more than 68. So we had enough for 75, we only needed enough for 68. If we've got 11 metres squared, this is going to be even bigger. So instead of 7.5 times 10, 7.5 times 11. So it's still going to be more than 68. So does it affect your answer? No. And we can say 75 was enough, and if the paint covers even more area, then it will still be enough, something like that. You could actually work out 11 times 7.5, but because it's the calculator paper, I would say don't bother. It's just time that you're using up. It's only 1 mark, we just need to give some words to explain it. Okay, question 23. Here is a Venn diagram. Okay, so we've got P and Q, and numbers are in different areas. So 18 means that it's in both P and Q. 12 means it's in P but not in Q. And these numbers are in neither P or Q. Write down the numbers that are in set P dash. P dash means not in P. Okay, so P is all 3 of these. So not in P is all the other numbers. So it's going to be the 10, the 14, the 11, the 13, the 16 and the 17. I'm going to write them in numerical order. So 10, then 11, then 13, then 14, 16 and 17. Okay, a number is chosen at random from the universal set. Find the probability that this number is in the set P union Q. So that means that it's in P or Q. So basically it's in here. So let's keep it nice and simple. If it's probability, we're going to write it as a fraction. And first of all, the denominator is going to be how many numbers are we choosing from in total. So even if you don't understand what it's asking, just think, what are the options? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 options. So it's going to be out of 9. We want the probability it's in the set P union Q. So I said P union Q means it's in P or Q. So it's 1, 2, 3, 4, 5 possible numbers. So it's just going to be 5/9. In fact, we can write that on our answer line here. Question 24. Sophie drives a distance of 513 kilometres on a motorway in France. She pays 0.81 euros for every 10 kilometres she drives. Work out an estimate for the total amount that Sophie pays. Well, if we're estimating, the number I'm going to estimate is this 513. And I'm going to say 513 is approximately equal to, or it's very close to 500. So if we want to know the cost, well then we're going to say it's 500 kilometres. She pays 0.81 euros for every 10. So we want to do 500 divided by 10. So just cancel a 0. That means 50 of those. And then we're going to need to multiply the 50 by 81 euros. So 50 times 0.81. But as you would have seen before, I ignore the zeros, I ignore the decimal points, and I'll just say 5 times 81. 1 times 5 is 5. 8 times 5, 5, 10, 15, 20, 25, 30, 35, 40. So we've got 405. Now, this is the bit where we need to be careful, because we took off a 0 here. So we put the 0 back on. That means we put a 0 back on here. And then we've got 2 decimal places. So we've got to go 1, 2. So we end up with 40.50. And that is in euros. Is your answer to part A an underestimate or an overestimate? Give a reason for your answer. Well, we rounded 513 down. So if we kept the real number, it would be bigger than what we've got. So our answer is an underestimate. Because I rounded down. Question 25. Here is a straight line L drawn on a grid. There's our L. Find an equation for L. Right, so hopefully you will know that the equation of a straight line is going to look like y equals mx plus c, where m is the gradient and c is the y-intercept. In other words, where it crosses the y-axis. Well, let's do that first, because it's crossing the y-axis at 3. So that's simple, that's just going to be 3. Now the gradient, that's how much up the line goes for every 1 across it goes. Now to show you that, what I like to do is try and find a nice tidy triangle we can draw, looking at where the line crosses perfectly. So we're going to take that point and that point and then turn that into a nice right angle triangle. And we want the difference in height. So this line is going up 1, 2, 3, and it's going across 2. So the gradient is going to be 3 divided by 2. So if we put that into here, we get that y equals 3 over 2 x plus 3. Write that on the number line, on the answer line over here. Instead of 3 over 2, you could put 1.5 x plus 3. Either one would be fine. M is a different straight line with equation y equals 5x. Write down the equation of a straight line parallel to M. So if it's parallel to it, it means the gradient is going to be the same. So in other words, the 5x bit is going to be the same. The only thing that's going to be different is our y-intercept. So instead of, we've got plus nothing here, we're going to need to have it plus something. So it's plus 1. You could do minus 1, you could do plus 5. Doesn't matter, as long as the number next to the x is still 5, and this is just a constant, it's just a number. Question 26. Kasim has some small jars, some medium jars and some large jars. He has a total of 400 jars. 3/8 of the 400 jars are empty. For the empty jars, the number of small jars to the number of medium jars is 3 to 4. And the number of medium jars to the number of large jars is 1 to 2. Write out the percentage of Kasim's jars that are empty small jars. 5 marks here. Lots of words, loads going on, so we need to split it down into smaller questions. This is all talking about the empty jars. So let's find out how many empty jars we've got. Because as we start off with 400, but only 3/8 of them are empty. Okay, so we want 3/8 of 400, so 3/8 times 400. Easiest way is work out 1/8 of 400. So divide 400 by 8. 8 can't go into 4, so 8 into 40. 8, 16, 24, 32, 40. Goes 5 times. 8 into 0 goes 0 times. So 1/8 is 50. We want 3/8. 3 times 50. So 3 times 5 is 15. Add the 0, 150. So we've got 150 empty jars. Now we're told the number of small jars to the number of medium jars, so we're talking ratios here. So as soon as we start talking ratios, I'm going to draw a ratio table. And we've got small, medium and large jars. So we're going to have small, medium, large. We also want a total column. So we've got 3 to 4. So for every time we've got 3 small jars, we're going to have 4 medium jars. Okay. And number of medium jars to the number of large jars is 1 to 2. So every time we've got 1 medium jar, we've got 2 large jars. So we've got twice as many. So if we've got 4 medium jars, we're going to have twice as many large ones, which is 8. Okay. So having these 2 separate ratios, we've now turned them into sort of 1. If we just had 3, 4 and 8, the total would be, 8 plus 4 is 12, plus 3 is 15. But actually we haven't got 15 jars, we know we've got 150 jars. So to be able to split this 150 jars in the same way, or the same ratio as the first row, we've got to think, well, how many times bigger is 150 than 15? So basically saying 150 divided by 15, well, 15 goes into 15. Don't know that. 15 goes into 15 once, 15 goes into 0, 0 times. So this is 10 times bigger. So we just need to multiply all of these by 10. So 3 times 10 gives us 30 small jars, 4 times 10 gives us 40 medium jars, and 8 times 10 gives us 80 large jars. We want the percentage of Kasim's jars that are empty small jars, so it's 30, but the percentage, so it's 30 out of the original 400 jars. So 30 over 400, because it's a percentage, we're then going to multiply by 100. Now, nice things happen. We can cancel some of the zeros. So we can cancel 2 in the division with 2 in the multiplication. So we end up with 30 times 1, which is just 30, divided by 4. 30 divided by 4, well, that's going to be, well, first of all, let's simplify it. They're both even numbers, so we can divide them both by 2. Let's do 30 divided by 2. 2 goes into 3 once, remainder 1. 2 goes into 10 5 times. So this is equal to 15, and 2 goes into 4 twice. So 15 over 2. So we've got 2, 4, 6, 8, 10, 12, 14. That's 7 and 1 left over, or 1 out of 2. So we've got 7.5. So if we're going to write that as a percentage, we'll write that as 7.5%. Question 27. In a sale, normal prices are reduced by 30%. The sale price of a TV is £280. Work out the normal price of the TV. So £280 is the sale price. So that represents 70% of the normal price. We want to work out what the normal price was. So in other words, the 100% price. So I'm going to start off by working out what 1% is. So we're going to do 280 divided by 70. Well, we can cancel the zeros. So we're left with 28 divided by 7. 7, 14, 21, 28, which is just 4. So what that means is £4 represents 1% of the price. So if we want to go up to 100%, well, obviously we'll multiply the 1 by 100. So we need to multiply the 4 by 100, which is going to give us £400. Okay, and finally, this is worth 3 marks. This one, question 28. Solve x plus 11 is less than or equal to 5 minus half x. The fact that it's less than or equal to is just fine. It doesn't matter what the sign is, just keep it as it is. Doesn't matter if it was equals. Some people would say change it to equals and change it back. There's no need to do that. You can just keep it as less than or equal to. Now, we want to get the x's on one side, the numbers on the other. So I'm going to get rid of this plus 11 by moving it to the other side and taking away 11. So the left side becomes just x. We've then got 5 minus 11. So think of a number line. If we've got 5 here, and we want to take off 11, well, we go 4, 3, 2, 1, 0, and then we go minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, so we've got x is less than or equal to minus 6, and then we've still got the minus half x. So all I've done is I've combined the 5 and the minus 11 together there. Okay. Now we've got this minus half x. So let's bring the x's across now. So we've got minus half x, bring it over to this x, it's going to become plus half an x. So if we've got 1 plus a half, we're going to have 1.5. So you could write that as 3 over 2x. It's less than or equal to. We've got rid of this minus a half now. It's got less than or equal to minus 6. Okay, so we've got 3 over 2, or 1.5 x's. Again, we just want the x. We want to get rid of the 3 over 2 bit. So this is dividing by 2. Move it over here so we change the sign so it becomes times 2. So we have still got the 3x, the 2's gone. This stays the same. Now 6 times 2 is 12. We've still got the minus. So 3x is less than or equal to minus 12. We only want 1x, so we're going to move that over. The times 3 becomes divided by 3. So we got that x is less than or equal to 12 divided by 3. 3, 6, 9, 12. That's 4 times. There's just one minus, so that stays. So x is less than or equal to minus 4. And write that on our answer line. So that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to my channel so you find out when I upload more videos, and I look forward to seeing you again soon. Thank you.